what we're going to do is we're going to start a discussion on radian measure. So before we've talked about degrees. Degree measure is really good when we're working with triangles. However, when we start working with circles and talking about angles and relating them to circles, it's more convenient oftentimes to talk about radians. And as we go along, you'll probably see why that's the case. But first, what we want to do today, first I want to define for you what a radian is. And then we're going to look at the relationship between degrees and radians. In other words, how we convert from degrees to radians, how we convert from radians to degrees. And then we'll look at some sketching of radian measured angles. Now, what I've done is I've used a GeoSketchpad to draw a circle up here. And you notice that I measured the radius. The radius is 5 centimeters. Okay. So this is a circle with a radius of 5 centimeters. And what I've done is I've placed a point on this circle. And I want to measure the distance of this arc from point A to this point up here. And I'll just say measure. And you'll notice right now the distance of this arc, the arc length here from E to A, is 1.96 centimeters. Now, as I grab this point E and move it, you'll notice that the measurement changes. It keeps up with the current measurement. Now, I want to keep dragging this point until I get a length that matches the radius of the circle, which right there it does. That's 5 centimeters. So I've got an arc length here that is the same length as from B to A, is the radius of the circle. Now I want to join those B and E with a segment. Okay. So now notice what we have. When I did that, an angle was formed. An angle that we can call A, B, and E. It's the angle that's made up of this line that passes through the center of the circle, the radius of the circle, and this other side, B and E. Now, of course, we notice that this is a central angle. This ABE, it's a central angle of the circle. Okay. And notice that this angle subtends this arc. Now this arc is a radius length long. One radius length long. When that happens, when you have an angle with that property, we say that that angle measure is 1 radian. In other words, when you take the radius length of the circle and have an angle that subtends that length, that angle is 1 radian. So this angle right here, ABE, is said to be 1 radian. Does everybody see that? Now let's try this again. Let's put another point here. And once again, I'm going to measure the distance from E to this new point. And I find it's 1.58. So I'll grab this point and drag it until it also equals 5. There it goes, 5. And I'll try the same thing. I'll put a segment there. Now, you notice now we have this bigger angle, A, B, and F. And it subtends 2 radius length arcs. Well, we say that this angle A, B, and F is 2 radians.
So a radian is 60 degrees?
No, it's not 60. Because, look, now, let's you'll see in just a second. You'll see in just a second. Now, let's look at it. Let's look at this again. And I tell you what, I'm going to put a little point down here and connect it. I'm going to construct a segment. Now, notice we've got yet another angle formed, and that angle begins here at A and goes all the way around and has a terminal side over here. Now, notice that this last segment here does not go all the way to the axis over here. In other words, it does not quite make it a third time around. I mean, three full, or it doesn't quite make it to the. What I'm saying is this: assume that this from F to this new point, assume that that is another radius length arc. Well, if I actually drew that, and the reason I'm not doing that in Sketchpad is because you can't really tell the difference. By the time I drew the 5 centimeters, it would look like it was all the way around half of the circle. So I'm just saying, well, let's call this. Let's suppose I did that again, and I've got a full radius length arc here. If I did that, and it was accurate in what we were seeing, it would not go quite all the way down. It would leave a little gap here. In other words, there's a little more than 3 radians in a half a circle. There's a little more than 3 radius length arcs on half of a circle. So, in other words, if I actually did measure, I would get a little less than 3, and I'd need to go a little more to make up a full half of a circle. Now, the number of radians that I would need to go to make a full half of a circle would be pi. There would be pi radians. Now, first of all, let me pause and ask, does everybody understand what a radian is? Well, it's the angle. Remember, it's the angle formed, it's the central angle formed by the 2 lines that subtends a radius length arc. In other words, if I take this radius and get an arc that's that long, the central angle formed there is 1 radian. You see that? Okay. There's a little more than 3 radians in a half of a circle. In fact, there are pi radians. Now you see why it's convenient to work with radians on a circle, because there is exactly pi radians on half of a circle. So let's look at this. What we want to take note of is this, that 180 degrees is equal to pi radians. We want to note that relationship right away, because what we're working toward, we want to define what a radian is and then look at how they're relating to a degree measure. In a circle, in a half of a circle, there's 180 degrees, or pi radians. Now, for a full circle, how many degrees are there? That's right, there are 360 degrees in a full circle. How many radians would that be? That's right, 2 pi. There's 2 pi radians in half of a circle. In other words, if you take these radius length arcs, there are 2 pi of them. Now, you start to see why we say the circumference of a circle is 2 pi r. Because we know that there are 2 pi radius length arcs on a circle. So if we want to know what is the distance around a circle, we'll just say, well, there are 2 pi. Now, how many radius? What's the radius here? 5, right? So this is 5 centimeters. So it looks like there would be 10 pi centimeters of length on this circle. So if you take how many radius length segments there are on a circle, multiply it by the length of one of those, you get the circumference. That's why the circumference is 2 pi r. Everybody see that? Now we're going to find that working with these radians is very handy when we're dealing with circles. Okay, let's look at the next thing here. Let's just look at some other angles. We've looked at 180 equals pi radians, 180 degrees equals pi radians, 360 degrees equals 2 pi radians. Let's look at some others. What about, now of course, let me just write this up here. 180 degrees equals pi radians. What do you think 90 degrees would equal?
Half pi radians.
That's right, half pi. If we divide both sides by 2, we get 90 degrees equals pi over 2 radians. Okay, what if we divide both sides by 6? What is 180 divided by 6? 30? Is it 30? Okay. So look at what we get. We get 30 degrees equals pi over 6 radians. See how easy these radians are to work with? There's fractions. And look, one of the things you know immediately when you look at radian measure, you know what fraction of half of a circle you're dealing with. I'm dealing with 1/6 of half of a circle. Here, when I have pi over 6. When I have pi over 2, I'm dealing with half of a half circle. Okay. Now, what if we divide 180 by 3? What do we get? 60 degrees, and that would be pi over 3 radians. What about if we divide 180 by 4? You get 45 degrees equals pi over 4. Are there any questions about that? Any questions? So we know what a radian is, and now we know some of the basic angle measures in terms of radians. Now let's be a little bit more general. Let's go back to this idea, and we want to go from degrees to radians. So let's suppose we have 180 degrees, and we know that that equals pi radians. Now you know, I'm going to write this a little bit differently. I know that this relationship exists. Well, watch this. I could write this as 180 times 1 degree, right? I could write this as 180 times 1 degree equals pi radians. Now you might think, well, why do you want to do that? Because now, what if I told you solve for 1 degree, like it was x or something, like an equation? What does 1 degree equal? That's right. Just divide by 180, and what you get is pi over 180 radians. Look at that. So we know this, that if 180 degrees equals pi radians, then we know that 1 degree is pi over 180. So, what about 5 degrees? Let's multiply both sides by 5. See what we get. We get 5 times 1 degree. In other words, 5 degrees. How many radians is that? All we're doing is multiplying both sides by 5. So there's the formula for finding out the number of radians, right? Just multiply both sides by 5. 1 degree equals pi over 180 radians, then 5 degrees equals 5 times pi over 180 radians, right? There's no denying that. Okay, now let's get a general formula. What about theta degrees? What about theta? Let's suppose we have theta degrees, and we want to know how many radians that is. Tell me what to write.
1 theta.
Okay, theta. That's right. Now look at this. This is your formula. If you have theta degrees and you want to convert it to radians, all you do is take that degree measure, multiply it by pi over 180, and you get a conversion. So that's what you want to remember. That's how you convert. Theta degrees equals theta times pi over 180 radians. That's your conversion. Any questions about that? Okay, no questions? Now let's go the other way, and then we'll put them together and just do some random conversions. Let's suppose we want to convert radians to degrees. So where would you begin on this one? What relationship would you go back to? That's right. We know that pi radians equals 180 degrees. We start with that. And then I can just view this as, well, this is pi times 1 radian. equals 180 degrees. Now, what does 1 radian equal? Well, it equals 180 over pi degrees. So see, this is fun stuff. We just start off defining what a radian is, and then this follows. Then we see a relationship between degrees and radians, and we can immediately see what the conversion is. So, without going through all the song and dance that we went through a minute ago, just give me a formula. Theta radians equals what? Well, look at this. Theta radians. If 1 radian equals 180 over pi, that's right. Just all you're doing is multiplying both sides by theta. That's right. Well, what I'm doing is I'm taking this. 1 radian equals 180 over pi, and I'm just doing what I do with equations, multiplying both sides by theta. And when I do that, I get theta on this side and 180 over pi degrees. So, if you have a radian measure and you want to convert it to degrees, just multiply by 180 over pi. And I'll highlight this one. This is another conversion here.
That 180 over pi is constant, right?
That's right, it's constant. Okay? Every time we'll just multiply by 180 over pi. Now let's look at just some various conversions. Let's suppose we want to convert 15 degrees to radians. Sometimes we'll be converting radians to degrees and sometimes degrees to radians. Well, all you do is take the 15, multiply it by pi over 180 radians. Now, how many times will 15 go into 180? Will it go 12 times?
Yes.
Okay. So this is going to be pi over 12 radians. Okay. Any questions about that? In other words, you just kind of simplify them. Okay. Now, I've got pi over 10. What do I need to multiply that by to get degrees? Pi over 10. What is it? That's right, 180 over pi degrees. Now, look, 180, look, the pi's cancel here. They divide out. 10 will go into 180 18 times, right? So this is 18 degrees. Okay, any questions? Okay, let's look at 130. We've got 130, oh look, I duplicated degrees there. Okay, 130 degrees. So that's, if we want to convert that, we just say, well, that equals 130 times pi over 180 radians. Now, we just need to simplify 130 over 180. 10 will go into both, right? 10 will go into 10 will go into 130 13 times. So that's 13 pi. And 10 will go into 180 18 times. Okay. Okay. Any questions about that? Okay, let's look at the next one. Here we take 1.6 times 180 over pi degrees. Now, I'm going to do two things here. This hadn't been an issue before. What form do we write the answer? The exact form or the approximate form? I'm going to write it first of all in the exact form. The exact form is where we do not approximate pi. Now let me show you. All I'm going to do here is take the 1.6 times the 180, and I get 288 over pi degrees. Now this is the exact form. As soon as we punch in that in our calculator, we're going to get an approximate form, because it's going to turn pi into some decimal representation of pi, and there's some error in that. That right there represents the exact answer. 288 over pi, there's no error in that. Now let's look and see what the error is. We're going to divide by pi, and this is the approximation. The approximation is going to be, and I'm going to round to the nearest thousandth. This is going to be 91.673 degrees. That is the approximate form. So throughout this class, oftentimes you're going to be asked, show the answer in exact form. And typically what that means is, do not find a decimal approximation to a square root, and do not multiply or find a decimal approximation to pi. If it says find the exact answer, you're likely to have pi in your answer or a radical. Now if it says approximate, give the approximate form. Well then you multiply, or you find the decimal approximation for your roots and pi. Any questions about that?